So I just wanted to give you a quick update on the status of the Turborocket Engine Mark VI testing. Here we see the Turborocket Mark VI motor assembly in its sort of disassembled state. And what I've been doing is I've been putting new orifices in the rotor assembly. In the Turborocket engine, the mixture ratio is established as a dynamic equilibrium solution to the system. And one of the ways you can change the mixture ratio in the system is by putting in the correct size orifices that will give you the desired mixture ratio at the dynamic equilibrium operating condition of the engine. In this case, what I'm doing is I'm trying to do some testing with some more logistically tractable propellants, a gaseous oxidizer and a liquid fuel. Because the rotation of the Turborocket engine imparts the isodynamic pressure increase in the system, liquid propellants, which have higher density, experience a much higher increase in the isodynamic pressure compared to that of gaseous propellants, which have a much lower density, on the order of at least a one or two orders of magnitude lower than a liquid propellant. And so because of that, the orifice sizes have to be set, and it can be difficult to achieve a particular mixture ratio if you have this big of a mismatch between propellant densities. However, I was able to find a solution using the gaseous oxidizer I'm working on and the liquid fuel. And I've sized the orifices such that they can accommodate a mixture ratio that will still give us suitable propulsion, suitable combustion, and engine operation. So in my engine here, the Turborocket Mark VI configuration, here's the rotor assembly, and in this design, the oxidizer goes down the center passage, and then the fuel goes down these offset passages here, and they enter the combustion chamber through a set of orifices that are shown here. The orifices on the upper edge, closer to the nozzle end, which are the oxidizer orifices, and then these orifices down here, which are smaller, are the fuel orifices. In the design I use here, I use straight gun drilled passages because it makes the fabrication simpler, especially for subtractive manufacturing. But it also allows one to clean out the flow passages and make sure they're clear of any swarth from the manufacturing processes. But this is also true if you're doing additive manufacturing and you'd want a way to make sure the passages are clear. And so by these through passages that are subsequently blocked with a plug, then you can do that. In this design, I'm using two fuel orifices that are quite small because those are the liquid orifices, and these are the orifices down at the bottom here. There are 4 ports, 1, 2, 3, and 4, but I'm only using 2 orifices. It's difficult to see the orifices down in there because they're very small. The fuel orifices are 0.016 inches in diameter. They're very difficult to kind of see. I don't think you can see them down there. Maybe you can kind of see that. Anyway, those are and I'm using 2 of those. The oxidizer, because it's gaseous and it's a lower density, the orifices are much larger, and I'm using 4 of them. You can actually see all the way through to the other side. That's the way the oxidizer passages are drilled through, because they're the farther aft flow passages. And those flow passages are 0.135. That's the size of the orifices that pass through there. So there's 4 of those. This gives a mixture ratio for the propellants I'm using that's still rather fuel rich, but it should give us some pretty good, reasonably good performance, and certainly enough to validate the operation of the Turborocket engine. These are made using basically set screws. For the fuel side, for the oxidizer side, those are 1/4-20 plugs, little like set screw kind of things. They look like, let's see if I can find an example. Here's one. They're basically just set screws, and I can drill those out to the orifice sizes that I want. The oxidizer, or the fuel side, are 1024 little set screws, and so those are smaller. I don't have, no, there's some examples right there. These are the 10 the 1024, you can kind of see the size variations between the 1024 and the quarter 20. Anyway, that's what I use for orifices, and I seal them with just some high temperature RTV. Other components for the Turborocket engine, you can kind of see the bearings here. This is a seal assembly, and then there's another shaft seal assembly down in there. Of course, this is the main cover, which is the effective combustion chamber for the system, and it has the spaces for the nozzles that are inserts that drop into this, into that space there. Those are also sized in terms of their beta angle, their relative angle to the axis of rotation, and also the throat and exit area diameter. And those can be sized and interchanged for various testing. Anyway, so that's what we have going on. We're getting ready to test. There's the back cover. This assembly will be bolted to the test stand, and then we'll get that assembly going and be able to get to some hot fire tests here, hopefully in the coming weeks and months. Let it rock.